is it too late to solve the climate crisis? Okay. Now, I feel that a lot of discussions about the climate crisis relate to quite short timescales, talking about impacts that are seen now or in the near future. So I wanted to look at this on a longer time scale, and in particular in terms of what's known as committed climate change. So I'm going to focus on global sea level rise and the melting of the Greenland ice sheet. Okay. So committed climate change, this means the future warming to which we have committed ourselves by virtue of past human activities. And because of the slow response time of the climate system, the equilibrium climate consistent with current levels of greenhouse gases will not be reached for many centuries. Okay, so one aspect of the climate system that changes relatively slowly and that illustrates this idea of committed climate change is global sea level. Okay. So here are some global mean sea level rise projections. So I copy pasted these from the NASA climate change webpage. And there are projections for 2030, 2050, 2090, 2100, 2150. And also the rate of change over this interval from 2040 to 2060, and here from 2080 to 2100. Okay, so the rows in the table. The columns of the table, they correspond to 5 emission scenarios. So reading from left to right, we can think of these as being very low emissions, future emissions, low future emissions, medium, high, and very high. And then in each cell in the table here, we see that there's a number given here. So this is, according to the projections, the most likely value for the sea level rise in meters. And here is a likely range that the sea level rise is likely to fall within this range. Okay, so we see here that if we look at the projections up to 2030, then here we see the same for each of these scenarios, and this value is only 1 centimeter higher. Okay, so we see a very small change between the scenarios when we look at the projections for 2030. In contrast, when we look for 2150, there we see a larger difference between the projected sea level rise for the different scenarios. So we see here that the projected sea level rise here of 1.32 meters for the very high emission scenario is more than double the rise here of 0.57 meters for the very low emission scenario. Okay. If we look at these rates here for these two time periods, we see that whereas for the lowest emission scenario, the rate for the later period here is only slightly, marginally higher than it is for the earlier period here. We see that for each scenario, there's a larger increase in rate as the the emissions increase as we go to a higher emission scenario. Okay, so from this, I think it's fair to say that we see larger differences between the projections from the scenarios when we look further into the future. and that in the higher emission scenarios, the rate of change shows the biggest increase between this time period, 2040 to 2060, and this one, 2080 to 2100. Okay, so let's have a little look now at these scenarios and just try to get a feel for what these correspond to in terms of emissions reductions. So here I'm showing a figure for the three lowest scenarios that were used in the projections on the previous slide. Okay, so I call them very low, low, and medium on the previous slide. And this curved arrow, this means that we have peak emissions. So that means in these two scenarios, the emissions would peak today. Okay, so that we would see more or less an immediate decrease in emissions. This medium scenario, this decrease in emissions looks like it's happening around 2040 there. And here we see that emissions would decrease to half their present day values here by about 2030 in this scenario, and by roughly 2050 in this scenario, and roughly 2100 in this scenario. And when we say a half, we mean net emissions. And here the zero represents net zero emissions. So in this scenario, we're talking about reaching that by 2060. And here this looks like it's about 2080. And here it's not reached not shown on this chart. Okay. So I hope that this gives some idea of the what the different scenarios mean in terms of emissions. If we were to look at the high scenario, that would correspond to really kind of no action against climate change and emissions that are increasing. And in the very high scenario, that would correspond to large increases in emissions. Okay. So on this slide, we're looking at things slightly differently. Again, this is taken from the NASA climate change website. The previous slide, the figure was taken from the latest IPCC report. I will provide links to all these sources in the description. Okay, so here we're looking at the year by which a rise of 1.2 meters in sea level above the the recent values over this recent time period. So a rise of 1.2 meters is expected according to the projections from the climate change models based on the scenarios. So according to this very high emission scenario, we would most likely see a rise of 1.2 meters at around year 2040. That would be the most likely value according to projected value according to the models under this scenario. And this bar represents a range of likely values. So we're saying that under that scenario, it would be likely that we hit 1.2 meters somewhere between about year 2120 and this looks like about year 2180 perhaps. Okay, and then each row of this figure corresponds to an emission scenario. Okay, so what we see here for this medium emission scenario is that the most likely time we would hit 1.2 meter sea level rise would be around year 2190. But that it's likely that we could hit that figure really at some sort of time after from 2140 onwards up to 2300 and possibly beyond. It's not shown on this figure. And then for this low emission scenario, then we expect to hit 1.2 meters around 22. This looks like about 2280 here, according to these projections. Okay. So what can we say here? We can say that if we compare these scenarios, if we compare, reducing emissions to here, to a medium level, or to here, to a low level, then we would still, in each of those scenarios, we would still see a rise in sea level of 1.2 meters before 2300. Okay. However, in this scenario, that figure would be reached 40 years before this one, and in this scenario, it would be reached this looks like about 80 years here before this one. Okay. So this illustrates the fact that even if we were to hold emissions low, then we could still see a quite substantial rise in sea level of 1.2 meters, but that by lowering emissions, you can basically make the sea level rise take place over a longer period of time. Okay. Now, what I want to do next is to look at an even longer time period. So to do this, I'm going to focus on the Greenland Ice Sheet. Okay. So here we have some figures for contributions to global mean sea level rise for 2100, again taken from the NASA climate change website, and now broken down into contributions from different aspects of the Earth. So, or from different, what can we say, sources, okay, of sea level rise. So thermal expansion, okay, from glaciers, from Greenland, from Antarctica, and from land water storage. Okay, so this table shows the results in a similar way to what we saw on the previous table, with the 5 scenarios of very low, low, medium, high, and very high emissions. Okay, and the most likely projected rise and the range of likely values. Okay, so what do we see here? We see that these are the 5 main sources of sea level rise, and that I guess in the low level scenario for this time period, then the contributions from Greenland are about roughly 10% of the total there. And then for the highest emission scenario, then let's see, this is about 1/6 of the total emissions there from Greenland. Okay, so this is the contribution that I'm going to focus on in the upcoming slides. So these numbers are taken from a recent research paper, and I'll provide a link to that in the video description. And here we're just focusing on projections based on 2 scenarios. So this one, which is called here RCP 2.6, this is what we call the low emission scenario. It corresponds to the low emission scenario from the previous slides, whereas this one corresponds to the medium emission scenarios. Okay, and we're looking at projected contributions to global mean sea level rise from the Greenland Ice Sheet. and we have projections for the year 2100, 2200, 2300, and 3000. Okay. So what we see is that in the lower emissions scenario, then here this is an interval of likely values. So we're saying that the sea level rise is likely to be between 0.05 meters and 0.19 meters here under this scenario for 2100. Okay, so what we see is that up to 2100, there's a relatively small difference here between the projected values for the two scenarios. And then as we go further forwards in time, we see larger and larger differences between the projections for the two scenarios. So projecting out to the year 3000 and to the low emission scenario, we're projecting between 59 and 191 centimeters of sea level rise, whereas for the medium emission scenario, it's between 197 and 416 centimeters of sea level rise. Okay. And of course, this is just focusing on the contribution from the Greenland Ice Sheet. Of course, there will be contributions from the other sources that were shown in the previous slide. So, to go back to my original question, is it too late? Well, what I would say here is that reducing emissions would be insufficient to hold the impacts from sea level rise at today's levels, because there's committed climate change that takes place on the timescale of decades, centuries, and millennia. And I've just shown the example of the Greenland ice sheet there. However, what we see is that the longer the timescale, the greater the benefits from reduced emissions. So the sooner we start reducing emissions and the longer we continue reducing emissions, and the longer that these changes kind of play out in the future, then the greater the benefits from the reduced emissions. Okay, so this was my best attempt to answer the question of, is it too late to stop the climate crisis? Thanks for watching.